In the previous videos, we looked at the basics of Hbase. In this video, I want to give you some pointers about where to go next if you want to learn more. Hbase was developed based on Google's Bigtable and was designed for random access. Many people view Hbase as the open-sourced version of Google's Bigtable. It's called Bigtable because you are really putting everything in one gigantic table with billions of rows and millions of columns. For Hadoop and HDFS, they are also based on Google's published work. For example, HDFS was based on Google File System, or GFS, and Hadoop MapReduce was based on Google's MapReduce paper published in 2004. If you want to know more about these techniques, I highly recommend that you read those original papers. The links are shown here on your screen. A lot of people want to know how Hbase is different from relational database management systems. The rule of thumb is that you want to use a technology that best meets your needs. At a very high level, Hbase may be good for you if you don't know the structure or schema beforehand. Hbase is flexible in that it allows you to add millions of columns on the fly, and is designed to handle sparse data where many cells may be empty. This is very different from relational databases, which are more suited for storing and retrieving whole rows of data. Hbase explicitly keeps multiple versions of the data, while relational databases do not. A very nice thing about relational database is that it supports multiple indexes, allowing you to write queries in much more flexible ways. In general, if you have very large datasets, like in petabyte scale, it will be a lot cheaper to deploy Hbase. There are a lot more to learn about Hbase. For example, there are commands that we have not covered, which would allow you to add and retrieve data in batches at high speed, instead of doing that one by one. Also, we did not touch upon cluster management and administration, which can have significant impact on performance. For example, Hbase region servers should typically have more RAM than Hadoop MapReduce node to speed up lookup. If you plan to use Hbase to store time-evolving data, you would want to be careful when designing your row key. For example, you would not want to use timestamps which are monotonically increasing as the row keys, because they can cause hotspotting, meaning even though you might have hundreds of machines in your cluster, only one of them is used at a time. The reason is that new rows are added to a single region instead of randomly distributed across machines. The links shown on this screen offer multiple solutions to help you avoid running into such problem. In this video, we discuss some topics related to Hbase that you may want to study further, such as row key design and the Google Bigtable paper that Hbase was based on.